Mechanical Engineering Division has taken up such an important initiative to be discussed today, particularly when the whole world is marching towards the net zero emission, including India. The Indian government is highly focused on infrastructure development, as you know, to boost economic growth. While the pandemic pushing back the growth by several years, work on housing, transport, infrastructure, and the power back in full force. Due to the usage of cement in such efforts, India is only second to China in being the largest producer of cement in the world. It is also fact that cement, a key component to concrete, is a major contributor to CO2 emission. Studies show that the cement 4.2 billion tons contributes about 7% of worldwide emission. This for cement are only going to increase due to the margin population and the need for housing and infrastructure. India too, along with the world, needs to fast track the journey to zero carbon emission. As need for energy is paramount in the cement industry, the solution is to emission issue lies in finding renewable electricity that can produce clean, safe, affordable, and infinite energy. Across the globe and in India, companies are in the process of changing their manufacturing techniques to transitions to clean energy being the second largest producer of sales, about 9% among the top countries in the world trying to create a sustainable future with clean energy. Manufacturing and usage of green cement can significantly boost the cement industry's effort towards a greener and cleaner future. It is a surprise to many that cement can also be green and sustainable too. I hope today's eminent speaker will be able to learn many things about the cement industry and the production, how can these issues can be achieved and can contribute a lot towards net zero emission march of India, which is first for 50, 2070, something like that. With this all, I'd like to request that hope you will enjoy this program today, the technology information. Thank you very much.
Thank you, Dr. Das, for
Anirban,
your
please.
welcome address. And may I now request Mr. Bhaskar Datta. He is a business consultant and retired vice president from the Tyson-Fook Industries Limited, and he is also the convener of Mechanical Engineering Division of West Bengal State Center of IEI. May I now request Mr. Bhaskar Datta to share a few words of the intent of this webinar and why this topic has been chosen for hosting this session, as well as to do the honor of introducing our theme speaker of today's session, Mr. Makarand Marathe. Over to you, Mr. Bhaskar Datta.
Good afternoon to everybody. It's a pleasure to again come back on the same subject of the CO2 emissions, which is a talked over subject all over the world. And, just to bring on page the new members who are on this webinar at this point of time, Mechanical Engineering Division, Institute of Engineers, organized a worldwide seminar on climate change issues and climate change menace, which is happening. And is it correct for us to get stressed up on this issue? What is the outcome of that series of webinars? There were about 4 or 5 webinars in which the whole stress is being given by the COP people and all the environmental scientists all over the world to stop use of fossil fuel. And I am of the opinion that India possibly needs a country-based prescription for each country to arrest or to address the CO2 issue. And in that respect, we brought in ex-chairman Coal India, Partho Bhattacharya. We brought in a director from TERI. We brought in Team Buckley from Australia. We brought in Elena Domes from Arctic region and many others. And more or less everybody agrees on the basic concept that it has to be on the basis of the needs of the country, because there are so many other economic and other issues which are definitely linked with this. While this is an important subject for the whole world, for the whole planet, but at the same time, the geopolitical situation of each country is also important for the purpose of addressing this GHG emission. CO2 is one of the largest contributors in GHG. So that from that point of view, I thought cement possibly contributes a major CO2 contributor, and in terms of the environmental pollution, it's also and I thought that Mr. Marathe can be the best person to address this issue on IEI platform and then make us aware. Mr. Marathe actually holds an engineering degree together with a management degree. He has served ThyssenKrupp in the lead management role for a couple of years, and then now he is acting as a business advisor in terms of the ThyssenKrupp. I have had a very pleasant relationship with him, and I have traveled together with in many situations where I have found him to be an objective, not only from the point of view of addressing an issue, but from the social issue, from many other points in consideration. Cement possibly, and my Dr. Das informed 7% is the CO2, but I read in one of the journal article as 8%, and these figures are definitely debatable figures which comes out of various calculations. So maybe Mr. Marathe will be in the best situation to address these issues, and that's how we have requested Mr. Marathe to come in, and out of his busy schedule, he has agreed to come online and say a few words about this. So that is the basic purpose of it. So with this, I don't want to extend my talk, and then I want Anirban to take it forward. Thank you, Anirban.
Thank you, Mr.
Thank you, Bhaskar. Thank you very much. Thank you very much.
So you have very categorically pointed out that IEI West Bengal State Center, the journey for the last about 1.5 years on our events we hosted, particularly focusing the issues on climate change and energy transition policies which could be adopted for India, and of course the necessity of country-specific energy transition policy. And both Dr. Das and you very categorically pointed out that emission from the cement manufacturing sector, that accounts a sizable number with respect to the world's total CO2 emission. Now we are fortunate today. We are fortunate enough to have Mr. Makarand Marathe, who is the business advisor at the cement division of ThyssenKrupp Industries India Private Limited. And ThyssenKrupp, as all the members of the audience, I believe they are aware that ThyssenKrupp is one of the largest conglomerate around the world, involved in metallurgical as well mining and power generation as well as cement manufacturing sector. And may I now request our today's theme speaker, Mr. Makarand Marathe, to address and enlighten us about the initiatives which could be taken up in production of green cement.
Before Mr. Marathe starts, I forgot to mention that Mr. Marathe is a very prolific writer. He has four books, to his credit, as well as he is an avid traveler. So that actually mixes up his whole blend of the presentation in terms. I'm sure he will make us aware of whatever is going on in cement and beyond. Okay, Marathe.
Bhaskar, you have been more than generous. Thank you very much, and thank you so very much. And I'm really overwhelmed. And Dr. Das, Mr. Anirban Datta, and all the elite members who are online at the moment. A very good afternoon to you, and it's a real pleasure to be part of this webinar. And thank you very much for this wonderful opportunity you have accorded to me to speak a little bit about whatever little I know about the cement industries, about the cement future, about the green cement initiative, which is a buzzword world around. So with these words, I would like to shift to my presentation. Let me see, we have tried it out. 1 second. Yeah, share Windows. Is the presentation visible, sir?
Sir, it is visible.
Okay, so I start. So once again, very good afternoon to everyone. And the topic which has been given to me is the Green Cement Initiative. And of course, I will not go into the speaker's details. I think Bhaskar was more than generous to me in describing me. I will only mention that about my practically whole career has been spent with ThyssenKrupp, almost barring the first 3 years with Walchandnagar Industries. The rest 43 years I've been with ThyssenKrupp Cement Machinery Division. So I've been quite involved with ThyssenKrupp plants to supply cement machinery in India, all around complete pan-India in the last 43 years. So now, typically sustainability is the buzzword, but we must critically look at what is sustainability. Now, sustainability generally perceived, it is related to environment. It is related to, I call it environmentalism as far as sustainability is concerned. But sustainability is not just environmentalism. It is also related to the social, human, and economic resources. Because sustainability means meeting not only our needs, but without compromising the ability of the future generations. So we have to ensure that our future generations keep getting their due, not only in terms of environment, but also in terms of social, human, and economical aspects also. So sustainability is not just environmentalism, and embedded in this definition of sustainability, there are concerns for social equity, economic development. I mean, we have to have a kind of a holistic approach, because the social infrastructure also needs to be built up over a period of time, not only environment, and there has to be backed up with the economic development. So that is sustainability. Now, as far as I see it, there are 4 major pillars of sustainability. There are social pillars, the human pillars, there are economic pillars, and there's environmental pillars. So these are the 4 pillars of sustainability. But today, with the topic which has been given, I think we have to focus more on the environmental aspect of sustainability. So let's go ahead. Environmental sustainability is primarily to improve the human welfare through protection of natural capital, as we see, which is a more perceptible and explicit meaning, which is known to us, that is air, water, minerals, and land. So this is what we have. We live within that, and that is something which need to be preserved for our generations to come. And all these initiatives which go in preserving these four components is the environmental sustainability. Now, initiatives are environmental sustainability when they ensure that needs for population are met without the risk of compromising the needs of future generation. So the emphasis has always been on the future generation, and that's the kind of sustainability we will have to ensure. We cannot rampantly go on utilizing or using the resources which are available, least bothering about the generations to come. No. So we have to take that holistic approach. Now, ecological integrity is maintained, of course, of the Earth's environmental systems are kept in balance with the natural resources are consumed by humans. So we have to ensure that the rate at which we are consuming these resources, land, air, water, minerals, we are able to replenish themselves in a specific period of time, so that the generations which follow us are not deprived of these fundamental issues. Let's go ahead. Now, what is a sustainable production? Now, sustainable production has a key role to play in maintaining the ecological integrity, as I mentioned earlier, which is relating primarily to the environmental sustainability. Now, sustainable production means what? Now, sustainable production is manufacture of products and services which are not harmful to the environment, clear, which saves energy and resources, absolutely clear. It is economically feasible, obviously, because they are in a business, are safe and healthy for not only for the employees, for the consumers and communities, and are socially and creatively rewarding. So this is what a sustainable production or a sustainable product, manufacture of sustainable product and services mean, in my opinion. So let's go ahead step by step. Now, coming to the focus area, that is the cement industry, what we have been talking about. Now, let us look at the role cement industry has to play in the industrial growth of any country. Now, cement is the most, as you all know, is a widely used building material. Without cement, all the urbanization which is happening, not only in India, but worldwide, is not feasible. Without the infrastructure which is created, cement is a very important component. And today, the global average, if you take, it's almost 530. Okay, there could be disputes. Some claim it at 550, 500. But let's say it's in the range of 500 to 550 kilograms of cement being consumed per capita worldwide. Now, this is a huge amount. And let's look at where India stands. It's coming in the subsequent slides. Now, cement.
Mr. Marat,
yeah, please.
Can you please just, your slides are not moving. Can you please shift to the slide share mode and.
Oh, I'm already in the slide share mode. Here it is. Now let me see.
Actually, can you please
shifted now?
Can you please click on that cup icon at in the PowerPoint bottom side of the PowerPoint?
Yeah. Yes, it is. It is. Yeah. Now is it visible? It is in the normal form.
It is in the normal form now.
Yeah. Now I click here. It's in the presentation form. Can you see the presentation form now?
No, it is not coming. The presentation form is not coming.
Oh my God. So is this visible?
This is visible.
So let's go on this basis. If it is not visible.
Okay.
Not at least, yeah. So we have talked about sustainable production, and now role of cement industry in industrial growth. Now we have been talking about the role of cement industry. As I mentioned, the consumption, per capita consumption worldwide could be in the range of 500 to 550 kilograms. Okay, 530 is the figure I mentioned here. Now, cement industry has a crucial role in all the urbanization, in building the social infrastructure like houses, dams, building roads, highways, airports, and it is like a commodity. I mean, it's not like an industrial product these days. All demand for cement is forecast to continue the increase worldwide. Now, all the infrastructural developments, projections will require cement. And especially in the emerging economies, in the APAC countries, India is a lead player, of course, China, with a massive urbanization is happening in India also. I mean, there is a different problem we are facing today because of a lot of shift. The manpower shift is happening from the rural and mufsil areas to the cities, because that's where the job creation has been happening. So all this population needs a dwelling and a shelter to stay in, and that's where the infrastructure development comes into play. So all this shifting, urbanization is taking place, triggering boom to housing and infrastructure. So this is how, in the subsequent slide, you will see almost 65% of our cement demand is from the housing sector. Let's go ahead. Then cement production and environmental sustainability. As on today, the cement is a binding material in construction activities. There is no substitute. There have been absolutely no substitute. What we are trying to do worldwide, the scientists are trying to do, is to reduce the carbon footprint, how the cement process could be made more efficient, devoid of the ills which it creates. Now, in terms of environmental sustainability, cement production requires water for cooling the machines and exhaust gases. So again, the second of the important environmental component is being used up is water. As cement plants are often located in remote areas, they draw water from the community sources, because cement plants are located where the mines are. And as you all know, the primary component of cement is the calcium carbonate or limestone, which is a mineral, and which is mined. So there, typically in India, if you take the Indian scenario, the limestone mines are more or less concentrated in the central part of India, southwest part of India, southeast part of India, and the west and the western part, the Rajasthan side. It is, and now we have found mines which are in the northeast part, though the reserves may not be as huge as you can expect to be in Rajasthan or the western part of India. But these are all located in pockets, and that's how the cement plants are located. They are close to the mines. So naturally, once they are close to mines, they are drawing or disturbing the environment, or drawing the environmental components like water from the community sources, which is creating a potential conflict with the communities. Then in cement industry has a huge impact on the environment as compared to other industries due to high energy intensity, leading to the CHG emissions. Now, CHG emissions, as you know, is comprising of NOx, comprising of CO2, comprising of other toxic gases, which sort of cover the universe and doesn't allow the heat to be dissipated. And in the bargain, our temperature of our dear Earth is increasing. Of course, it is coming in the subsequent slides. Let's go ahead. Now, attending sustainability, what are the key factors and viable solutions relating to the cement industry? Now, first is a product innovation and operational efficiency measures, which are required to reduce the resource consumption of water and energy, reducing the CHG emission. Resource management and waste management are the best ways forward. So the first and the foremost is some kind of innovation is invited, essential, and to achieve higher operational efficiency. When I say operational efficiency, is in terms of the heat consumption, in terms of the kilocalorie consumption, that means the energy consumption, and heat consumption. So these are the two key components and two key parameters which are used to measure the performance of a cement plant. So the measures, the innovative measures need to focus on these two parameters. The viable solutions include production of green cement. Now we'll come to that. What is green cement? Which will reduce the reliance on the depleting fossil fuels. Now, as you know, in a classical cement plant in India today, we need about 700 to 730 kilocalories per kg of clinker produced. That is a kind of fuel consumption we require. And this is being provided from the fossil fuels. Typically in India, it is coal. Today, the shift is to the pet coke. There is hardly any plant, in fact, none, which uses oil because it is equally dear to us. We are importing oil. So primarily the resource which is used is a fossil fuel, and we are heavily dependent on this, and we are sort of brutalizing our fossil fuel reserves and damaging the environment. Enabling water conservation, environment, biodiversity, protection, negating the effect of CAG. I talked about CAG emissions. So enabling the water conservation, because cement plants are consuming water. So there has to be technologies which will, evolving technologies which will use less and less water in the process. That these need to be focused on. So just to summarize, water conservation, biodiversity, negative impact of CAG, and these are the targets for sustainability for future. So as far as cement is concerned, this is the focus area. Let's go ahead. Now, as I mentioned earlier, Indian cement industry profile, if you look at, typically there are, I'm ignoring the other small consumers, but primarily 65% is from the housing and the real estate sector. 10% is the commercial and industrial development, and 25% is the infrastructure building, So all the roads and dams and what we talk about is taking about 25%. But the massive consumption today is happening in the housing and the real estate sector, which is 65%. Now, let's look at the Indian cement industry profile. Now, today, Indian cement industry is dominated by few companies, as you all know. Ultratech, you can count them on the fingers of one hand. There is Ultratech, which is a leading cement producer. Now Adani, with that massive takeover of Lafarge and Holcim plants, it's almost 70 million tons. Ultratech is in the range of 150 to 155 million tons. Total installed capacity in India is about 550, 560 million tons. So you can see a chunk of the capacity lies in these 2-3 large companies. Then there is Shree Cement, there are Dalmia Cement in the range of 45 to 55 million tons. Then there are small regional strong players like Madras Cements, 15 to 18 million tons, India Cement, about 12 to 14 million tons, and there are many more. Wonder Cement, with the 4 lines of almost 2 million tons each, are already about 10 to 12 million tons. So these are the regional players which has a stronghold on the regional markets. They are manipulating, they are cultivating the regional markets in their own way. So it is the top 10 to 12 companies account to almost 70-75% of the total cumulative installed capacity in India. Now, per capita consumption vis-a-vis the world, we are talking about 530, as I mentioned in my earlier slide. India is somewhere around 240, 250 kgs. Now, which clearly shows that there is a huge potential. If we have to catch up with the world averages, there is a huge potential which exists in the consumption of cement in years to come. Now, average thermal energy consumption and average specific electrical consumption, as we call it, the heat consumption and the power consumption in the Indian cement industry is 740. Now, 740 is an average, because the modern plants today are talking about 660, 670, 680 kind of heat consumption. But the old plants, the wet process kilns, the old plants, 30 years old, 35 years old, are requiring more heat. So an overall average of 740 and around 80 units per ton, that is the power consumption average. There are some modern plants which are in the range of about 65 to 75. Of course, this, when I'm talking per ton of cement, so it depends that if you're going to add more and more additives, which we will come to later, this value will go down for sure. Now, this is compared to the global average of 830 and 91. So this is very surprising. Now, today we are talking about a very attractive parameters in terms of heat and power consumption vis-a-vis world. How is it possible? Because it is simple. Because worldwide they are not really bothered about they are using the alternative forms of fuel. They are really not worried about the fossil fuel consumption. They are going with alternate fuels. They are going with natural gas fired plants. They are going with municipal waste. They are going with, I mean, so many alternate fuels, which we'll touch upon a little later. So in the process, they are compromising on the heat consumption, but at the same time, they are conserving the environment. Let's go ahead. Now, Indian cement industry profile, as we talked about, I think the cement industry alone contributes to about 6% of the total global man-made CO2 emissions. Now, this could be, as Bhaskar said, there could be a dispute on this. It could be 7%, 8%, but by and large, I would say 6 to 8% of the total man-made CO2 emissions worldwide are contributed by cement process. The CO2 emission intensity of the Indian cement industry in 2021, which was measured, is around 576. Now, typically from 1 ton of cement produced, around 750 to 760 kgs of CO2 is released. Now, the question is why this 576 is a low figure? Simply because then there are composite cements, there are blended cements, you add additives, and the overall effect thus is reduced. Now, despite this progress in enhancing cement efficiency, the greenhouse, the CSG emissions from the cement sector are still significantly high, which is about 180 billion tons of CO2 in 1920. Today, I was told, I was just taking the net, it is in the range of 205 million tons in 22-23. So these are staggering, mind-boggling figures, and that is something that needs to be addressed as early as possible. Now, what is a greenhouse effect? Of course, you know, but this is just a quick slide. As the greenhouse effect is the way the heat is trapped, as I mentioned. The notorious gases which sort of engulf the earth consists of carbon dioxide, primarily methane, nitrous oxide, and water vapor. So these are the greenhouse gases which engulf our dear earth and which doesn't allow the heat which is coming from the sun to be reflected back, and certain amount of heat is retained, and as a result, this is a very interesting observation, the carbon dioxide adversely affects the Earth's atmosphere. Yes, if you remove the carbon dioxide from the engulfing gases, the terrestrial greenhouse effect would collapse. That's what the scientists say. They say without the CO2, Earth's surface would be some 33%, 33 degrees cooler, which is phenomenal, mind-boggling. So you can imagine the kind of negative effect the greenhouse gases are having on Earth, and in which CO2 has a very significant role to play, and indirectly cement industry. Let's go ahead. Now, what are the concerns for the global warming? One of the most pressing concerns or the most important sustainability issue today is global warming. Now, as we talk about global warming has led to increase in temperature of the Earth's atmosphere, temperature of the sea water, and in the second bullet you can see that the global climate report released by the US National Oceanic and Atmospheric Administration says that the global and land ocean surfaces was 1 degree less than average 14.8 degrees in the 20th century. So, okay, 1 degree is something which is insignificant, but see the gigantic effect it has over a period of, let's say, 4 decades or 5 decades. Now, United Nations report finds that by year 2030, which is not very far from here, emissions are expected to reach 54 to 56 gigatons of CO2 equivalent, far above the level of 42 gigatons. Now, 42 gigatons has been identified as the level at which there is some hope or chance of limiting the global warming to about 2 degrees. So we are already surpassing that. So obviously, we are heading towards global warming by more than 2 degrees. That is preposterous. I mean, that is quite scary. Now, green cement initiative. Now, green cement can be defined as a cement which uses waste material, at least one of its component, or its production process does not lead to environmental destruction. So this has generally been defined as a green cement. Traditionally, as you know, that cement process involves sintering of the cementitious material, which primarily consists of limestone. You have the what we call it additives. You have bauxite, you have iron ore, you have sand, and when you fuse or sinter, then clinker is formed, and this clinker, when ground with gypsum, is cement, which is popularly called as ordinary Portland cement. Now, with these initiatives, if you go on adding the cementitious material in clinker, obviously the contribution of clinker in the per ton of cement is going to reduce. We'll see it in the subsequent slides how it's going to happen. So cement production, as we mentioned, 6% of the global, 6 to 8%, let's put it that way, global man-made CO2 emissions, and thereby is a third ranking producer of man-made CO2 in the world. Now, production of 1 ton of cement results up to, I mentioned, 756 to 760 kgs. That's 0.76 tons of CO2. All 55% of it is coming from the process, and that is something inevitability of the cement manufacturing process, because as you know, the limestone primarily consists of calcium carbonate, that is CaCO3, and when you are calcining it, you are allowing the CO2 to be released. So CaO remains and CO2 is released. So almost 55% of emission, on which at the moment we do not have a very significant control, which is coming from the process emissions. 35% is coming from the burning of fuels. Yes. Now, fuels contribution is about 7 to 8%, but 35% of the CO2 is coming from fuel. So that is something which we can control. We can use alternate fuels. We can use something out of the box thinking as far as usage of fuel is concerned. And 10% is coming from electricity use and transportation. Now, electrical power, now how is it connected with CO2? Because the generating plants from which the power is drawn from, the grid power as we call it, are again fossil fuel based. So the more you optimize your power consumption, indirectly you are reducing the carbon footprint at the production level and the transportation. So these are the key initiatives behind green cement. Now let us go ahead. Now, staying with the initiatives, the major objective behind green's concept in cement is carbon mitigation. This is the whole game is being played to finally arrive at carbon mitigation. We are trying to reduce the carbon footprint which cement industry is creating. So that supports the sustainable transition of the cement sector. So carbon mitigation is the key word. Now, what are the carbon mitigation levers? Now, carbon mitigation levers is reducing the clinker to cement ratio. As I mentioned some time back, per ton of cement includes 95% of clinker and 5% of gypsum. This is the classical ordinary Portland cement. But if you have the PPC, the Pozzolana Portland cement, in which fly ash is added to the tune of 30 to 35%, indirectly reducing the clinker component, indirectly reducing the carbon footprint, because per ton of cement you are reducing more and more reducing the clinker component. So that is how the carbon mitigation process or the levers are defined. So reducing the clinker to cement ratio, switching to alternate fuels. As I mentioned, 35% of the CO2 generation or emission is coming from fuel. So shift to alternate fuels, which will reduce the CO2 emissions. Improve your energy efficiency. Now, energy efficiency improvement will be an indirect reduction in carbon footprint. If you improve the energy efficiency, your consumption of grid power will reduce. Naturally, the generation, the fossil fuel utilization also will reduce, and indirectly it will reduce the carbon footprint. Integrating emerging and innovative technologies such as carbon capture and storage. Now, this is a new concept. What the environmentalists and what the scientists feel that almost 25 to 30% of the exit gases consist of CO2, the cement exit gases. Now, this CO2, instead of being released into the atmosphere, is proposed to be trapped, to be isolated from the exit gases, But what is to be done with this CO2? Because it is harmful to the environment anyway. So this needs to be captured and stored. We'll come to that slide. So this is, again, it's a huge exercise. How to store, where to store. It's a subsoil storage, whether it's to be stored in the ocean, whether it's to be stored in mines, and how it is allowed to be released, and what is to be done with that. So these are the mind-boggling issues. But this is a new field which is coming up. Okay, it's in a very nascent stage in India at the moment, but carbon capture and storage is the future as far as I see. Now, just a minute. Now, as far as carbon mitigation is concerned, the first point was reducing the clinker to cement ratio. As I mentioned, from a classical ordinary Portland cement, which has 95% of clinker, you can go on adding cementitious material to ensure that the quality and the quality requirement, the settings, the setting time, the workability, the strength, the 24-day strength, the 7-day strength are still maintained. You have the adequate standards to produce this kind of cement. You can reduce the clinker. Now you can add fly ash, you can add granulated blast furnace slag, you can add limestone, you can add natural pozzolana and calcined clay. Now there is something interesting here. The maximum percentage of use of these substitutes are, as per the Indian standard, the cement standards, fly ash you can add up to 35%, which directly will reduce the clinker component to almost 60%. Ground granulated blast furnace slag can go up to 65%. But in doing so, the slag needs to be of a certain quality, certain chemical phases, certain chemistry needs to be maintained. But typically in Indian industry, I think up to 50 to 55% of granulated blast furnace slag can be utilized. So for which you need to maintain certain high quality of clinker. So, I'm not going to all that chemistry part of it, but this is how the balance takes place. And the natural pozzolana up to 35%. Now, there's an interesting development, which is a new field again, and that is called as LC3. That LC3 is limestone calcium clay cement. The C comes, the 3 C's, that's why it's called as LC3. Now here, you have in the clinker, you can substitute. Next slide is there. Let me go ahead. Yeah. So what is LC3? Now LC3 is a ternary cement that can achieve the required strength like OPC. That's important. Even at the clinker factors as low as 0.4 to 0.5. That means per ton of cement, you can just 40% of clinker is required. The remaining is a blend of crushed limestone and calcined clay. Now, those who know a little bit of the cement chemistry, obviously the question will come, how just a limestone without being calcined can be used in the final cement? The answer to that is because of the calcined clay. Now, when you partially calcine the clay, and which will make it highly reactive. Now, this highly reactive calcined clay along with cement and the classical clinker will give you all the attributes of a normal cement. Now, calcined clay and limestone is used to substitute the part of clinker in blended cement. So clay is typically containing 50 to 60% of the kaolinite. Now, but for that, you need very special type of clay, which will have 50 to 60% of kaolin. And in India, we have found there are clay storages in Rajasthan. They have found something in the northwest part of India. But these reserves need to be very carefully investigated. The clay needs to be carefully investigated, analyzed, and only if it is found suitable, it could be partially calcined and then can be used as LC3. So this is a new field which is emerging, and I'm happy to convey that Government of India had constituted a steering committee to go into the details of LC3, feasibility of manufacturing LC3 in India. IIT Delhi was a part of that, and I understand that only few months back a standard has evolved, like a normal Indian standard, and which gives the quality requirements of LC3. So that it is a reality now. Now the question is, there are few cement producers like Dalmia Cement and maybe Shri Cement. They have done extensive experiments on the clay which is available in the Rajasthan side. They have found that clay is useful with the requisite amount of kaolin in it, and which is suitable to make the LC3 is a kind of cement. And let us go ahead. Now, just to give you an idea how the calcined clay cement, or LC3 as we call it, the first, just a comparison, first column is product, second is the total CO2 emission, and third is the cement quality. Now, Portland cement with 95% clinker is taken as a basis, as a reference. You have 750 kgs per ton of CO2 emission. If you go with the blended cement, 20% limestone, you can come down to 600 kgs. If you go with further composite cements of 30% of additive materials, you can come down to 550. But if you go with LC3, you have dramatically come down to 450. So this is a paradigm shift as far as the total CO2 emission is concerned. So that is the technology of the future, I would call it. Now, staying with carbon mitigation, switching to alternate fuels. Now, switching to alternate fuels, that is byproducts from the domestic industry and agriculture sources, can be used as fuels. Though they may be of low calorific value, but still they can be used as a fuel. You need a special modification in the calciner, in the machinery, in the preheater, and which needs to be undertaken by the machinery manufacturers, which will enable partial or full replacement of traditional fossil fuels. And today, worldwide, it has gone up to 75, but I think there are plants in India. I have seen in Germany, in the plant in Legedorf, they are going up to 94%. That means almost 94% of their fuel requirement is met with through the alternate fuel. That is significant and that is substantial. In India, as far as I know, the overall average is still hovering around 10 to 12% or 8 to 10%, let's say, primarily because of the initiative. I mean, the government of India feels that the responsibility of procuring the alternate fuel, the municipal waste, the agricultural waste, the pharma waste should lie with the cement producer, which somehow is not working out. I'm not going into the details of what is right, what is wrong, but that's how the cement producers are not willing to take over that responsibility, and they are looking at the government to give them a product, an alternate fuel product in a certain sorted out fashion, you know. So but that's not happening. So our overall TSR, as we call it, as a thermal substitution rate, is still in the range of about 10 to 12%. Now, the commonly used alternate fuels are tire chips and whole tire, municipal waste, sewage sludge, industrial waste from paint industry, biomass like rice husk, nutshell, etc. But here, gentlemen, you will see that we need a lot of organization. You need classifying centers of dry fuel and the wet fuel, and all that. The cement producers are not willing to take over this responsibility. There are examples, I believe in Andhra Pradesh, My Home Cement is doing that. Then there is one more near Hyderabad, that is Sagar Cement is doing that. But there are very few, handful of cement plants who have taken over the responsibility of collecting the alternate fuels, sorting the alternate fuels, and then utilizing and contributing to the environment. Then again, staying with the carbon mitigation, then improving the energy efficiency. Now, obviously, as I mentioned, you improve the energy efficiency, you reduce your power draw from the grid. So indirectly, you reduce the fossil fuel utilization in the power plants, and then you reduce the carbon footprint. So this is contributing, as I mentioned, 55, 35, and 10. So almost 10%, but still it is significant percentage of the total CO2 contribution. So today, as you probably must have heard, that the classical ball mills, which were used for grinding, are being replaced with high pressure grinding rolls and vertical roller mills, wherein you can achieve savings in power to the tune of 11 to 14 units of raw material. You can go with the peripheral equipments, and the main peripheral equipment which controls the cement process is the process fans, the preheater exhaust fan, the cooler exhaust fan. So that is available with high efficiency. Today we are talking of fan efficiencies of 82, 83%, which in the former times was around 70, 74%. So 6 to 7% of more saving on the fan power can be achieved these days. You can use variable speed drives to optimize the pressure and the volume combination, and then optimize the power consumption. Then we have multi-string and low pressure drop cycle on a preheater. That means you are designing cement plant machinery in such a way that you require low powers. Your power consumption is reduced. Then you have waste heat recovery systems utilizing exhaust gases from preheater. Typically, I would say, if you go by the thumb rule, I think it's mandatory now to go. All the greenfield plants need to go with a WHR system, with waste heat recovery, and instead of allowing the heat to be thrown into the waste to the environment, you recycle it and generate power and make sort of sustainable. You become sustainable. And so today, a million ton plant is about 3,000 tons per day. You can expect to generate about 3.5 to 3.7 megawatts of electrical energy, which you can utilize yourself and reduce the grid consumption. Staying with carbon mitigation, we are on improving the energy efficiency. I mentioned we can use the variable speed drive. You can optimize your power consumptions. You can use high pressure grinding rolls and vertical mills for clinker grinding also, not only in the raw grinding. In the earlier slide, we have seen the raw grinding. In the clinker, that is clinker to producing cement, you can reduce 6 to 10 units. Then process control, you can employ the digitalization concept. You can optimize the fluctuations in fuel. You can fluctuations in the raw. And these are small, important, but precious steps with which you can, the contribution may not be huge, but still it contributes, and it is measurable, and it is significant as far as the environment is concerned. And then you can go with high efficiency motors. Today, we are talking of HT motors of 94, 95, 96% of efficiency, which in former times used to be in the range of 84 to 86%. So there is a substantial saving. Now, we talked briefly about the carbon capture and storage. Now, carbon capture and storage is the process of capturing and storing carbon dioxide before it is released to the atmosphere. Now, this technology, there are technologies available. I'm not going to these technology details because that could be a separate session. The technology can capture up to 90% of the carbon dioxide released by burning fossil fuels. So this carbon dioxide is not allowed to be sent into the environment. And the S part, that is carbon capture, and S is the storage. Now, storage is the challenge. Now, the chain consists of three parts. That is capturing the carbon dioxide, transporting the CO2, and securely storing. So that's S becomes extremely important. So where to store? Surely it has to be stored underground or deep saline formations. That means you can do it in the ocean. Then they can do it in the abandoned mines. In the Indian perspective, still we are in a very nascent stage. The commercial deployment of CCS has some distance to go, and I think we will take at least few more years, maybe 10 years, 12 years, before a very viable, feasible, economically viable alternatives and options are available. This not only technology part of it, but it needs to be supported with government legislations. There has to be law, there has to be implementation, there has to be a steering group, there has to be a monitoring group, and all this needs a lot of government interaction, or so that it is still some distance to go. Summary: the carbon mitigation, adaptation of best practices leading to reduction in carbon footprint. As I mentioned, CO2 emission level reduced from all these, what has been initiated worldwide and in India, the total CO2 emission level has reduced from 1.12 tons per ton of cement in 1996 to about 0.72 now, and targeted to go to 0.5 tons in 2030. Now, it will be interesting to know, gentlemen, that Dalmia Cement has drawn a way forward. They have, in the international conferences, they have announced that by 2030, they will be carbon neutral. The complete Dalmia Cement group, which will be carbon neutral, and that is something which is a phenomenal achievement if they really do so. And they are employing various such measures in the process. It will be a very interesting case to observe. Particulate emission has been reduced from 400 milligrams per nominal cubic meters to 50 milligram, and now the norm has gone even beyond. The new legislations talk about 20 to 25, so we are on the right track to reduce the environmental pollution, particulate environmental pollution, to almost 20, and that's a paradigm shift from 400 milligrams to 20 milligrams. Then the low carbon roadmap, which is the carbon mitigation, that is just to summarize, enhanced generation and utilization of power from the waste heat recovery that I mentioned, because a 1 million ton plant, you can generate about 3.5 to 3.7 megawatts. Eco-friendly use of hazardous industrial waste. Now, industrial waste, instead of dumping it in the environment, can be utilized. So the processes need to be modified. The machinery, if some design needs to be tweaked and refined, has to be done. Enhanced utilization of fly ash generated from thermal power plant. Now, thermal power plant, if you recall that it was being dumped in the open fields. Now, fly ash being extremely fine, because that's the fly ash which escapes and is trapped in the ESP. It's in the range of about 20 to 30 microns. Now, this is a extremely fine fine fly ash. Now, if you just dump it dry, it is going to fly away and pollute the environment. So this needs to be dumped in a water pool. So that was creating its own hazard, because even if you want to utilize the fly ash, a huge amount of water is required to be evaporated. So there again you consume heat. So the whole balance needs to be looked at. But at the end of the day, the standard Indian cement standard for PPC, that is the Pozzolana Portland cement, allows fly ash addition up to 30%. So more and more cement plants in India are shifting towards producing PPC. Sustained utilization of 100% slag generated by steel plants, because we have strong steel plants in terms of its production, and a lot of these new initiatives, the grinding units which are coming in the vicinity of steel plants, so that they can use slag, because slag in a certain chemical composition is a cementitious material. It exhibits cementitious properties. So when it is ground with clinker, can be a slag cement. It can be used in the infrastructure. So this is a new initiative. So that is a sustained utilization of 100% slag. Participation in the Clean Development Mechanism, that is a CDM projects under the Kyoto Protocol. Now, Government of India has signed the Kyoto Protocol of the United Nations Framework of Convention on Climate, that is UNFCCC. So we are very much part of the Kyoto Protocol. We are bound by the responsibilities, the global responsibilities, and the world definitely is watching India, because traditionally it is perceived that like China, India is one of the biggest polluters. It is not really true, because the kind of cement industry, the parameters which they look at and with which they govern the cement process, we are making dramatic strides as far as going to the carbon neutral environment. Adopting renewable energy, that is wind, biomass, and solar. I think this is not the forum to talk about these things, because we still have some distance to go. But the present government has laid huge emphasis on the solar and wind power, and which is evident if you go to Gujarat, or if you go to South Tamil Nadu or Kerala, a lot of wind farms, a lot of solar farms are coming into being, and the target is they are talking about 180 gigawatts in next 10 years time. So definitely that will reduce the fossil fuel consumption in the power plants. Now, coming to the cement machinery part of it, because all we have looked at the process, we have looked at the fuel, we have looked at the cement raw material. Now, as I mentioned, you can optimize the power consumption by utilizing high pressure grinding roll, which is again produced by ThyssenKrupp, and there are other manufacturers also which is producing high pressure grinding rolls, which can dramatically bring down the specific power consumption. Then comes the vertical mills. As you know, traditionally we were using the ball mills. The ball mill was most inefficient way of grinding raw material as well as grinding cement, and in doing so, you were wasting a lot of energy. The kilowatt hour consumption per ton of cement produced can be reduced dramatically, almost by half, if you're going with modern technologies, the vertical mill or a high pressure grinding roll, not only for limestone but for clinker production also. So vertical roller mills are produced by a number of manufacturers across the globe. So this is the initiative with which you can reduce the power consumption. And as I mentioned, in the machinery itself, you can go with higher stages. Now, just a word about the number of stages. Now, 5 stage to 6 stage of preheater. That means you are changing the calcination degree which is going into the kiln. So you can go with a 6 stage preheater. You are using more and more optimized usage of the heat which is available. And by increasing the heat, the number of stages, you are reducing your heat consumption. So this is innovation which is already in place, and preheater is associated with efficiency and with low pressure drop cyclones, and this is a technology which has come to stay. It is available, which is being widely used, and which has contributed a great deal as far as heat and power consumption is concerned. It also can cater to the low NOx calciner. It means NOx is again a greenhouse gas, and which needs to be controlled. There are strong legislations in place, and I must compliment the government that they are taking cognizance of the pollutant, the environmental pollutant, and they are bringing in legislations to control this. So NOx legislation also is in place. Also, there are low NOx burners. All these details, which primarily the NOx which comes from fuel as well as it comes from the raw material. Now, there is a thermal NOx, which is the biggest contributor to the NOx. The thermal NOx is a NOx which is generated during the burning of the fuel, which takes place in the burner itself. So we have to design burners which are combusting the fuel with a low NOx generation. That's what we call it, the low NOx fuels. Now, all the leading manufacturers, including ThyssenKrupp, has this technology in place with them. So this is being used in the modern cement plants. And lastly, I have talked about the waste heat recovery system. Now, waste heat recovery is something which ThyssenKrupp also manufactures, and more than 50-60 plants supplied in the cement plants. So here, a 1 million ton plant can give you about 3.5, 3.7 megawatts. The thumb rule is about 1.2 to 1.5 times per 1,000 tons of cement produced. So to give an example, a 10,000 TPD plant can generate about 11.5 to 11.8 megawatts. So that is a kind of value we are looking at. Indirectly, we are reducing the carbon footprint in the power plant stage. Yeah. That's all from my side, gentlemen. I think thank you very much for your patience.
Really, we are thankful to Mr. Marathe for the extremely lucid and wonderful presentation. And
thank you, sir. Thank you very much.
You all are enlightened with your sharing of thoughts. And really, there are many issues because we perceive cement as a commodity, but and also it is an ingredient for the development of the infrastructure. And practically our idea, for many of us, the idea is limited only to as the end user. But the production of cement and the equipment and technology involved, those you have wonderfully, you have touched upon the areas, particularly focusing on the production of green cement. So before the session is open for question answer, may I now request Mr. Bhaskar Datta, who was also in the same organization where Mr. Marathe belongs, that is the ThyssenKrupp industry, because ThyssenKrupp is one of the largest technology provider in various sectors, starting from steel and metals, non-ferrous, power generation, mining, as well as cement manufacturing. So I request Mr. Bhaskar Datta, who is also practically he is a passionate crusader for the cause of climate change. May I request Mr. Datta to add a few words on this?
So after I've heard Mr. Marathe having talked about the Green Cement Initiative on especially addressing the sustainability issues, and I'm quite pleased he has touched upon the social and other issues other than the technological issues. I don't have a very clear idea about the cement process, so I would refrain from making any comments on his, and I would not be in a position to talk about it. But at the same time, I have two, three things which I wanted to pop it up, whether it makes sense for Mr. Marathe to pick it up. See, 240 kg per capita consumption as against a 530 or 550 global average. Is it not related to the population density, which we have about 1.4 million tons? So as far as the industry scope is concerned for the expansion, for reaching from 240 to 500 or 550, whatever Mr. Marathe has spoken, that 240 is possibly, I would assume, it is actually derived from the total consumption divided by the
population.
So if that is the case, then it ought to be much lower. So many people, many scientists say that India's contribution in terms of the GHG or CO2 is much lower, primarily from the per capita contribution. So from that point of view, Mr. Marathe has very lucidly talked about the various initiatives which are being taken by the cement industry manufacturers. And with this, I think I will give it back to Anirban to take it forward in terms of the question answer.
Let us open the session for the questions from the members of audience. Now we invite members of the audience to type their questions in the chat box, and our speakers will be delighted to answer your queries.
Ji.
So before questions from the members of the audiences come, may I ask a query to our theme speaker?
Sure.
Manufacturers, you have very certainly you have covered the manufacturers' side and their focus and impetus on the production of green cement and various technological routes. But as far as the policymaker side and as well as the end user side, because most of us are perceived, as I have mentioned, that perceive cement as a commodity for the development of. So, what are the awareness level and what are the eagerness of the consumers or end users to promote or to handhold or to encourage the cement producers or manufacturers, at present in India particularly?
Uh, Interesting question. I think you are very right that these initiatives normally I call it as a boardroom initiatives, and the finally the consumer is a man on the street, and he's really not having an opinion, but the opinion is viewed, or rather, is by the mason, and the mason finally has his own perceptions about cement. वो सफेद दिखना चाहिए, वो ग्रे दिखना चाहिए, इसमें ताकत होती है नहीं होती है, he has his own, but he's not really bothered about what is his 7-day strength or 15-day strength or 21-day strength. He has a typical notion कि I'm just throwing this names. वो L&T cement अच्छा रहता है, क्यों? Because वो सफेद रहता है, वो ग्रे रहता है, सफेद नहीं रहता है, ग्रे रहता है, उसमें ताकत ज्यादा होती है. Now, this is something which needs to be, they need to be educated, they need to be sensitized. And I think all these big manufacturers, like Ultratech or even Shree Cement or Dalmias, are having regular sessions, interactions with the final users. What you should look into the cement. ये पतला है, thick है, क्या है, इससे slurry बनती है, नहीं बनती है, concrete अच्छा होता है, नहीं अच्छा होता है. All these things need to, because finally the user is not that elite. He's not that educated. He doesn't have that formal qualification, but he knows how to use the cement. He knows how to, play with it. So this needs to be done. And I believe so that these big manufacturers, from whatever interactions we have with our customers, they are busy and they are educating the masons finally, the stockist, because stockist is a very key member who holds the cement bags and finally sells it to the consumers, has that kind of knowledge. And I think the awareness, I wouldn't say it's 100% aware, but it's significantly increasing. Have I answered your question?
Thank you for, you have very correctly you have pointed out. So we are now having questions from our members of audience. Mr. Deepta Sundar Malik from Development Consultants, Director of Development Consultants, he has put up a question that even though OPC and PPC have almost similar property, why many of the public works departments still do not accept PPC?
I think I don't think I'll be able to answer that, because see, there is no reason that why PPC should not be accepted. Because purely going on, because finally the cement is the strength, and because initial strength is the final strength, the 7-day strength, the 28-day strength. Now the typical mentality of a constructor is that how quickly the scaffolding can be dismantled. So he is looking at a very strong early strength than the final strength. Because final strength he has to wait. The curing time has to be there, and then so probably it is emerging from this logic. But I really don't see, as far as the PPC and OPC is concerned, there should not be any differentiation in terms of quality. There is no reason, unless there are some extraneous reasons in it.
Mr. Nikhilesh Kamisetti, he has asked that is green cement useful for future?
Absolutely, because green cement is the green part is coming basically from the environmental conservation. And as I mentioned, the LC3, that is a limestone calcine clay cement, it has all the ingredients of cement. We are not compromising as far as the cement quality is concerned. Now, LC3 has its own standard in terms of 7-day, 15-day, 28 days. So it has to conform to this. The clay which is going to be used has to have a certain reactivity, has to have a certain kaolinite content. So I don't think there will be any compromise as far as cement quality is concerned. Now, if the specific applications are there, that is the suboceanic constructions where you need certain sulfate-resistant cement, or so these are separate niche areas which will be tackled the way it is now. But the green initiative will surely the cement of the future, no doubt about it.
Yeah, absolutely correct. Mr. P.S. Ranjit Kumar has put up a question that kindly elaborate on particulate emission, what it refers. I believe with respect to the manufacturing of cement.
Yeah, particulate emission. See, there are 2 points in which the particulate emission takes place. Primarily is the preheater exhaust gases. Now, preheater exhaust gases are partly used in drying of the raw material. They pass through the raw milling system, but finally it has to be exhausted into the atmosphere. Now, ESP or a baghouse, which is used as a dedusting mechanism, which traps the particles, which are the submicronic particles, which are carried by the dust. But earlier times, it was not effectively possible to trap 100% of the particulate dust, just like the fly ash, which finally flies away. So similarly, in this case, the standards used to call for 200 milligrams per nm cube of cement, which is exhausted, gases which is exhausted. So that has been cut down to almost 20-25 now. So this is one aspect of particulate emission, and this particulate emission is what it is. It is consisting of partially calcined clinker, so which is getting into the atmosphere, which will obviously is going to be hazardous. Anything submicronic particles hanging in the atmosphere are injurious and hazardous to health. So that's how the particulate emission needs to be controlled, and that you need legislations for that, which are in place now.
Absolutely correct, sir.
Yeah.
And today's discussion, which we got enlightened from you, practically the main focus was to reduce the particulate emission, because as all of you, you yourself and Mr. Bhaskar Datta, as well as our chairman, Dr. Nirmal, they have pointed out that all of you have pointed out that cement industry emission that account a sizable number. Mr. Deepta Sundar Mallik of Development Consultants, he has another question that is it nowadays mandatory to go for waste recovery system for a new cement plant?
Yes, that's what I understand, and the provisions need to be made definitely, and it makes sense. See, finally, I must mention here, even if there is a provision made, finally it's the game of cost of fuel versus cost of power. If your cost of fuel is offsetting the cost of grid power, then it doesn't make any sense. Finally, it's an economic game. But knowing the grid power is costing between 7 to 10 rupees, depending on the geographical nature of the country, generation of WHR generation is definitely going to be order of the day. There's no question about it.
Mr. P.S. Ranjit Kumar has another question. Adopt calcined clay with kaolinite as an alternate to clinker. Do we really have the material available all over India to meet the per capita demand? This is a very interesting question.
Yeah, you're right. And as far as I know, because this is a new territory, new domain for us also, and as far as I know, there are initiatives from individual cement producers, as I mentioned, like Dalmia Cement, Shree Cement, and there are one or two others. I think JSW is doing a lot of work on that. But this is available. It needs of a certain quality and a certain characteristic, which is available only in certain pockets in India. So it is not so widely available that it is can be used by each and every cement manufacturer. No. You need a certain type of clay, and there has to be elaborate tests done on this, and then only it can be used as a cementitious material.
The person, I'm not sure, Mr. or Miss Mr. Basanta Lakshmi Venugopal posed a question that time is a prime factor to make any project economical. Is it possible to get easily get early strength in concrete by using limestone calcined clay?
I don't have the details with me. I'm sorry, I will not be able to give the figure. I don't have it with me. But no, I think there is certain deviation as far as the early strength is concerned. As far as I know, LC3 is not complying with the early. It is complying with the standard, yes, But in terms of the relative early strength with the other options available, it may not be. But the final strength, yes, it can meet the requirements.
Mr. Yashwant Shakarande, his question is, what is the possibility of using oxyfuels to reduce participation of 78% nitrogen in air intake as source of oxygen? In this case, carbon dioxide gas will be heat transfer medium and CCS capture efficiency will be almost 99%. Mr. Marathe, can you please elaborate on this?
Yeah. First of all, Yashwant, a big hello to you because he's a former colleague of mine, and so good to connect. Yes, you are right. Oxyfuel is something which is the in thing in Europe now, and you are very right because in oxyfuel we are eliminating the nitrogen part of it, and we are ensuring the combustion is taking place in pure air, pure oxygen. So the combustion efficiency is going up. As far as this manufacturing efficiency definitely improves, but you are right. Oxyfuel and carbon capture has to go hand in hand, because only using oxyfuel is not going to help, because that will enable you to capture carbon easily, but then the problem of subsequent transport and storage of carbon remains. Now, coming to the oxyfuel part of it, creating pure oxygen also is a big process, and it's a very economically intensive process, and which I think on the Indian context, it will take quite some time to come back, because Policius, our principals in Germany, are executing a project with oxyfuel, but that also, it is a consortium of Heidelberg and Schwenk Cement and these big players in Europe. As a consortium, they are installing a plant in which oxyfuel will be used. Yashwant, I don't have the economics part, the figures readily available with me. I'm sorry. Maybe I'll come back to you separately on that.
Yeah. And Mr. Nazrul Hussain Majumdar, he has a query that rusting of rivers is a serious concern in RCC. Can there be any solution in adding some quality to cement?
Reverse means desilting part you are referring to? The desilting part? I mean,
Mr. Nazrul Hussain Majumdar, can you please type a bit elaborately about your query in the message box? So till then, we are skipping to the next question, requesting Mr. Nazrul Hussain to kindly elaborate his query a bit in the chat box. Mr. P.S. Ranjit Kumar has asked that will this green cement contribute points to secure green building certification for new construction? I think this is also a very interesting question with as far as the policy matters are concerned.
Yes, I think it has been talked about, surely, but I am not aware whether there is any initiative because this is something. See, we are on the other side of the game. We are cement producer side. So this primarily the initiative which has come from the cement producers and the government. So at least I am not aware of that such initiative has taken place from the producer side. I mean, certifying the green part of it.
So definitely there should be a score with the member of the audience. We also agree that there should be some score or point if the green cement is used in the construction of a building. So that should also be included in the relevant policy and regulation.
Exactly. But that's something which the CMA, the Cement Manufacturers Association, is a very strong body in India. So that is a pressure group which has to, take these initiatives. Machinery manufacturers is primarily supplying machinery to produce green cement.
So Mr. Nazrul Hussain Majumdar has elaborated a bit on his query that on the rusting of rivers query. He has mentioned that he meant carbonization and subsequent rusting. So is there any particularly using green cement I think his query is to, is there any, or adding some quality to green cement, is there any mean to uh, reduce this rusting in the reinforcement bars,
No, as far as I can
which
make
occurs
it
due
out,
to
that
carbon dioxide?
primarily he's probably referring to desilting of the rivers and the sand to be extracted, and then that can be used as a additive. Yes, principally sand is required because the silica component is coming from sand. If there is no interstitial sand in the limestone or the additive materials, then physically sand up to 5%, 6% is added. So all this desilting part of silting part of the rivers, if it is undertook, I think as a sand, yes, as a component, but not only as a green cement, even for a normal cement, it can be used.
Now, Mr. Anjani Kumar has, his question is, can green cement be economical?
Uh, Difficult for me to answer because it'll if we're talking of LC3, it is yet to be proven. But if you are talking of the other mitigation measures, then yes, it is economical because you are optimizing your heat and power. So it has to be economical. It will be economical.
So yes, he has elaborated his query a bit, that can green cement is economical with respect to construction time and cost. So I think again this is project whether I think he is to know whether it can be beneficial for the overall project schedule. And we had another query from another member of the audience, that whether to have early strength is in concrete by using limestone calcine clay. And definitely, I believe that there will be subsequent developments,
Yes.
and still this process will undergo much more R&D, and definitely these are the need of the hour to produce such a key commodity for the development of infrastructure in a more sustainable way.
True.
Because
True.
that sustainability is also attached to it with a cost factor.
True.
Definitely those today or tomorrow, those issues has to be addressed in a more holistic manner.
True. Because it's a relatively new development as far as the Indian scenario is concerned. And as I mentioned in my talk, that government of India had taken that initiative with IIT Delhi leading the steering committee group. And now I understand that already a cement standard is in place. That is, the LC3 standard is in place. Now, obviously, there will be some feedback from CMA. Obviously, there will be some feedback from the cement producers regarding the viability, regarding, I mean, pros and cons. And there are certain changes, certain debate is expected on that. And as you rightly said, before it is really settles down to a viable standard, it may take some time.
We have another question from Mr. Deepta Sundar Mullik, Director of Development Consultants Private Limited, that he has asked that we read from various literatures that even 80% alternate fuel can be used, whereas in our country is hardly, it is 10%. We work for a cement plant in South India, and found that quality deteriorates if the percentage goes beyond 20%. Can you please throw some light on this?
Yeah, I think this is a point which has been debated often in various forums. See, alternate fuel, if you are looking at which is available in India, is a municipal waste and the lime sludge, and these are high moisture alternate fuels. Now, these are not only high moisture alternate fuels; it also has fluorides. Now, the moment you get into this, the higher percentage you start firing or start adding into the process, you need higher, the exhaust gas goes up because the higher moisture needs to be evaporated. you have to have measures in place to mitigate the chlorides. So you need to install a chlorine bypass. You need to install. So there are fundamentally tweaking and refining of the machinery also needs to be and then that may not prove to be very effective. And as you rightly said, today in India, usage is still limited to 10 to 12%, where globally it has gone up to 94% in the plant I visited in Germany. So, but there, the supply of alternate fuel is done in a very organized manner, and the responsibility is taken by the government. Here, it is a debatable point whether government has to take the responsibility or the user has to take the responsibility. In India, it is not so. Finally, it is left to the user to fend for himself, to collect the alternate fuel, to sort it, segregate, transport, and utilize. You know, though there may be incentives in place, but still, all this the users are not willing to take the responsibility. And there are process-wise, there are side effects. Surely, I mean the primarily the chlorides and the moisture. So this needs to be addressed. Depends on what kind of fuel, alternate fuel you're using.
Mr. P.S. Ranjit Kumar has another query that can you please elaborate on why horizontal ball mill produce more CO2 emission compared to vertical roller mill in clinker grinding?
It is actually an indirect benefit. See, a horizontal ball mill, I mean, ball mill per se is not contributing to the CO2 emission. Ball mill is consuming more power. See, in a horizontal ball mill, if you need about 38 units to produce 1 ton of cement, you know, in a vertical mill, you will do it in 22 units. So almost half of the power is saved. Now, this power is somewhere at the manufacturing level is reducing the carbon footprint. I mean, we have taken a holistic view. I mean, per se, ball mill is not contributing to the CO2 reduction. But by reducing power, optimizing power, you are helping to reduce your power demand, you know, and then reducing the carbon footprint. That's how it is.
Yeah. Thank you, Mr. Marathe, for very nicely explaining all the queries coming from the members of the audience. So we are no further live query. So I have from the moderator side, I have one query that you have very correctly pointed out while answering the queries of the members of the audience, that the cement manufacturers are standing in the midway. On one side, the government and the policymakers, and other side, the users. So this cost of, because we had few queries on the economics part of the green cement. So what would you recommend, whether this the additional cost, because the cost, definitely production cost will come down with time, and one point of time it will be mandatory and people will definitely accept, the users. But till then, one part is the incentives, announcement of incentives, and I mean probably provision of incentives from the government, and another part is to pass through the additional expenditure for the production of green cement on the consumers. So between these two options, or taking a midway route, what would be your recommendation?
I think government is going to be the key facilitator in all that, because finally, if you just to go back a little bit, and you remember maybe 15 years, 20 years back, when the fly ash cement came into being, it was a classical market of ordinary Portland cement. So when government was forcing the cement producers to use more and more fly ash, so the incentives were there that the fly ash was given free. The fly ash was transported to the cement plants free of charge. So they were just to get rid of the fly ash from the environment. So these kind of initiatives only government can do. And then, just like as I mentioned, the facilitator has to be a government. He has to facilitate in terms of legislation, in terms of rules and regulations, and environmental quality. So government has to play a key role in all that. No question about it.
Yes, you are practically, you made me nostalgic, because when I started my career in a thermal power plant, at that point of time, the utility companies has to pay for dispositioning the fly ash, and at this point of time the situation is reversed, because the utility companies now earn from anything between rupees 700 to 950 per ton, and by exporting their fly ash to different cement manufacturing industries in the close vicinity or at a bit distance. So there are issues there with handling, and definitely those solutions as well. So definitely we got enlightened with your sharing of thoughts in different technological aspects, as well as the economics and the benchmark figures of the energy requirement as well as the emission. And definitely it will be our pleasure to hear from you in future as well. So we have now come at the concluding part of, as there are no open query from the members of the audience, we have now come to the concluding portion of the webinar. And may I request Professor Dr. Raju Baushak, Honorary Secretary of West Bengal State Center IAI, to kindly propose the vote of thanks.
Thank you very much. Is it audible?
Yes, sir. Yes, sir.
Thank you very much for giving me the opportunity to propose the vote of thanks. Thank you. So it is my proud privilege to extend my sincere thanks and gratitude to all the distinguished participants in the technical webinar on the theme Sustainable Production Green Cement Initiative, organized by the Mechanical Engineering Division of West Bengal State Center IAI to online platform. At the outset, I convey my sincere thanks to Speaker, Mr. Makarand Marathe, Business Advisor at
Thank you very much. Thank you.
ThyssenKrupp Industries India Private Limited, Mr. Bhaskar Datta, Business Consultant, Fellow Institution of Engineers India, and the Chartered Engineer also, Convener of Mechanical Engineering Division, West Bengal State Center IAI. My sincere thanks also goes to Dr. Nirmal Das, Chairman, West Bengal State Center IAI, Engineer Anirban Datto, Chief Technology Officer, Meshia Engineers, and Joint Honorary Secretary, West Bengal State Center IAI, who acted as a moderator of this program. So that the same feeling is also being showered to all the members of the council and division board members of MCDV, and all members of the committee, West Bengal State Center IAI, and all members of Mechanical Engineering Division of Subcommittee, Director Technical IAI, and his team for their wholehearted support to make the program a success. Last but not the least, my sincere thanks also goes to all those persons who are behind the screen and giving their silent support to make the program a success. Thank you very much. With this, we are concluding our today's webinar here. Thank you very much.
Thank you, sir. Thank you very much. Thank you. Thank you. Goodbye. Bye-bye.
Thank you, Dr.
Thank you, sir.
May I now request Dr. Kingsuk Sen of IAI headquarters to kindly discontinue the live streaming.
Thank you, sir. Thank you very much. Bye-bye.
Bye-bye. Bye-bye, Makarand.
Bye-bye. Thanks, boss. Thanks.